All right, we have a last 2 lectures, then we'll be done for this summer session. So 20 and 21. So let's see 20. We're graphing functions. So this one is called absolute value function, because you see this 2 bar, that's absolute value sign, right? So when we have expression in absolute value sign in the function, we call absolute value function. So here actually talking about the transformation of functions. If you will remember transformations from high school, we have 3 kinds of transformations, right? The first one is called a translation. You can imagine translation like this, right? If I have a point here, I go straight. If I go straight up, I push this point up, or I push this point down, or I push this point to the right, and push this point to the left. This is called translation. And second is reflection. So let's see, I have a point. Let me erase this. I have a point here. I can reflect over x-axis. Then x-axis will be my line of reflection. So the point was here. So reflect over x-axis becomes a point here. Also, I can reflect over y-axis. So point here, when I reflect over y-axis, the point becomes here. Or I can reflect this point over any line. It could be a straight line. I mean, a vertical line. I can reflect. So this vertical line will be called x equal to 4. I can reflect this point over the other side of this line. That would be this point. Right? So on and so forth. That's called reflection. And then lastly, we have dilation. So we have these 3 kinds of transformations. So dilation basically, basically, let's see, if I have something here, let's see, if I have a line here, so from this point to this point, I have this line segment, this long. I can dilate, I can make it longer, like maybe this is like a 3, so this length, maybe let's call it L. Then I can see this becomes 3L. Or I can shrink. It becomes only this much, it becomes 1/3 of L. Dilation. Actually, there's another one, rotation. Yeah, I can rotate. If I have a point here, I imagine the coterminal is this one, coterminal, right? I can rotate. So the angle, rotation work with angles. If this angle is a theta, then I can rotate this point, let's say 90 degree. Maybe I can rotate the point to be here. So you see here, I rotate this point 90 degree counterclockwise. So I get the point to be here. All right, so how does this transformation appears or demonstrates in our functions? Because the one I just draw is appears in graphs, right? But how does it correspond to the algebraic function? Let's see this one. So this one we call reference graph. Reference function or reference graph. Excuse me. So its a graph just like this. This is a V shape, right? This upward V. This keeps going, and this also keeps going. It's this V shape. And we call this graph reference graph. So we transform this graph, we can get this one. Let's call this G of X. Let's not use the same name. So let's use a couple points to compare those two graphs. Those two functions. Let's say X value, F of X, G of X. If I pick X value to be 0, we see F of 0 is 0 because the absolute value of 0 is still 0. For G, I have absolute value of 0 is 0, but I have plus 3. So for G, I get 3. If X equals to 1, F of X is 1. And the G of X is 4, because 1 plus 3 is 4. If X is -1, absolute value of -1 is 1. F of -1 is 1. And the G of -1, absolute value is 1. 1 plus 3 is still 4. Okay. If X is -2, excuse me, I get F of -2 is 2, but G of -2 will be 5. 2 plus. Let's just do one more. Let's say positive 2. We still get a 2, we still get a 5. Now let's graph. So F of X is already here. So this Y, you think as F of X. So let's graph G of X. We have 0, 3. Right. 0, 3. 0, 3 here. We have 1, 4. 1, 4. We have -1, 4. -1, 4. We have -2, 5. -2, 5. We have 2, 5. You see the symmetry, right? Just like quadratic functions. We have this line of symmetry. And we know the V shape. So straight line on the left-hand side, straight line on the right-hand side. So that's the graph. So how does the graph change? You see, this is 0. So this is still called a vertex. So here the vertex is 0, 0. But here the vertex is 0, 3. And if we compare, we see every value. It's just being added 3, right? 0 plus 3, that's 3. 1 plus 3, that's 4. 1 plus 3, that's 4. 2 plus 3, that's 5, so on and so forth. So every point of this reference graph being pushed up 3 units. You see right here, right? So another way of thinking about it is a G of X can be written as F of X plus 3. So that's why G is a transformation of F. G actually is a translation of F. Every point is being pushed up 3 units. All right, now let's see 2. 2, the reference function is square root of X, so the graph is here. So we can remember a couple important points, right? For absolute value function, you see this is a 1, 1. And this is a -1, 1. And the y-axis is a line of symmetry. Right? And also you can see this one. That's 5, 5, because the absolute value of 5 is still 5. This is -5, 5. Okay. And if we want to mark this, we see -1, 4, -2, 5. Is 1, 4, 2, 5, right? You see all the comparing those two graphs, the y value of the second graph is 3 times 3 is being added 3 from the first graph. Now let's see 2. 2, let's also remember a couple important points. Square root of 0 is 0, so 0, 0, the origin is the starting point of this graph. This is called a radical function. It's a square root of x, it's a radical function. Right, you see x cannot be negative. X only takes 0 or any number bigger than 0 in the domain. So the graph of this, let's remember a couple of points. So 1, 1, because square root of 1 is 1. And 4, 2, because the square root of 4 is 2. Right? So those 3 points are good enough. But the shape of the graph is like this. This is smooth. Let's compare this one. Let's call this G. Right? Let's do G. Since we pick a 0, 1, 4 for the x value, so let's use that for this one, for G of x. So G of 0, if we try, there'll be 0 minus 4, no good. We get a square root of -4, right? Not in real number system. So G of 0 does not exist. So we have to start with G of 4. Because G of 4 is 4 minus 4. That's 0. So we get 1 point, right? We get 4, 0, get this point. 4, 0. Then maybe we do G of 8. G of 8 is a minus 4 square root of 4, which give us 2. So I have to go a little bit further. So this is 8. G of 8. Then I get 2. Right, so this is 8. So this point is a, 2. Or maybe I get a G of 5. That's square root of 5 minus 4. That's square root of 1, which is just 1. So I get a 5, 1. So 5, 1. I get this point. Then I know my reference graph looks like this, so I try to graph exactly the same. I try to graph smoothly, so not a straight line. Right. So that's the graph. Right. This point is 5, 1, and this point is 4, 0. So I also get 3 points on the graph. Comparing this graph, we see the G function is, the graph of G function is being pushed 4 units to the right, right? You see the x value, 0 now becomes 4, that's 0 plus 4. 1 now becomes 5, that's 1 plus 4. And the 4 now becomes 8, that's 4 plus 4. So the x value be added 4 from the original function f. So we call that, so this one we can write as f of x minus 4. Okay, let's compare these two. Let's see what is the difference. Let me change my color. So here, G and F differ by 3. So this can be written as G of x minus F of x equals to 3, right? Because this is addition here. So G and F differ by a number. So we know that's a translation. Yeah. Vertical translation. So this is called a vertical translation because it goes up and down. Because this is at 3, so it goes up 3 units. If this is 1 minus 3, it will be going down 3 units. But here is a horizontal translation. Horizontal translation. So going to the right or going to the left. Because here is a minus, so going to the right. If this were plus, that would be going to the right. So those are 2 kinds of translations. You know, up and down, vertically, or left and right, horizontally. Let's see, 3 and 4. 3, that's our original function. Let's call it G. Right? Comparing G and F, we see this negative sign. We see this negative sign. So let's just graph a couple points for G, because for X we already have, right? So let's say X, then G of X. Then this will be X, G of X point. So let's pick this X value. That's 0, 0. Right? So X value to be 0. Then G will be -0. Well, -0 is still 0. So we still have this point. We still have 0, 0. Now pick X to be -2 maybe. Then we see -2, +2. So if X equals -2, that's negative. So G of -2 is a negative absolute value of -2. Well, absolute value of -2 is 2. So get -2. Get -2. So we have -2, -2 point. So -2, -2. We get this point. Now let's get +2. +2. Then G of +2 is a negative absolute value of 2. That's a -2. So still -2. So we get to 2, -2. So we get a 2, -2. We get this point. Right? If we do more, we could see, but we have straight lines, so 2 points are good enough. So let's draw a line on this side. Let's draw a line on the other side. So comparing those two graphs, you see this graph, the F graph becomes a G graph is by doing upside down. So this is reflection over x-axis, right? Because the graph originally was going this way. Now be reflect over x-axis. So where does the reflection come from? From this negation, from this negative. You see, all the y value, +2, be negated to be -2. So this is 2, -2. This is -2, -2. Yeah, so on and so forth. So this is a reflection over x-axis. But in our graph, we don't need to graph this one, because we only need to graph G. So this is a graph G. So this is a graph G equals to negative absolute value of x. So this is reflection over x-axis. Let's see this function, quadratic function, right? X squared. So this is its graph. Let's mark a couple important points. So I have 0, 0, 1, 1. Maybe pick another one. Pick 2, 4. 2, 4. On the other side, same thing, by symmetry. -1, 1. -2, +4. Right. Now here, let's compare those two. This is just every function value being multiplied by 2. So if we get a couple points, so pick up, so x, let's call it G. G of x, then the point x, G of x. Right. Let's pick x to be 0, -1, -2, 1, and +2. Okay. So G will be 2 times 0 still 0. So get a 0, 0 point. -1 squared still 1. 1 times 2, 2. Okay, -1, 2. Then -2 squared 4. 4 times 2, 8. So -2, 8. Well, 1 by symmetry, that's 2. So 1, 2. And 2, 8. So now let's graph from 0, 0, -1, 2, and 1, 2, and -2, 8. 2,8 is off the chart a little bit. So -2 is here, 8 somewhere here. And then +2, 8 somewhere here. So the graph goes this way. So the graph, you see, is being stretched, right? So G is the stretching of F. G is the stretching of F. So this point is 1, 2. This is 2, 8. You see the function value be multiplied by 2. Right here was 1 times 2, 2 times 4, 8. Where does the 2 come from? It's from this. So this is a dilation. Dilation, or in function world, we call scaling. So these 3 kinds of transformations apply to functions, function graphs. Let's see 5. So absolute value function. Then this function we see, okay, vertical up shifting. So this is shift the function up. But then before that, we have this scaling. We have this scaling. So what do? We pick 3 points for absolute value function. 3 points are good enough. Pick the 0, 0. Maybe you pick a 2, 2. A -2. So this -2, 2. -2, 2. Pick these 3 points. Right? If it's a 0, 2 times 0 is 0, I have 3. So 0, 3, we have this point. If it's 1, 2 times 1 is 1, 1 plus 3, that's 5. So 1, 5. If it's -1, same thing. By symmetry, -1, get a 5. If it's 2, 2 times 2 is 4. 4 plus 3, that's 7. Get this point. At this point. Now let's graph. That's it. That's a graph of G. So maybe you'll mark this 0, 3, 1, 5, 2, 7. The other side is similar, right? -1, 5, -2, 7. So we see the graph, the transformation is just stretching the original reference graph F, then push up 3. Push up 3. Oh, you know what? I'm not supposed to do everything on one graph. Let me redo this. So we do step by step. Let's do the stretching first. Let's do 2 absolute value of X. All right. So 0, 0 still have this. But then 2, 2 now become 2, 4. 2, 4, right? Because 2 times color, we have these 2. 2 times 2. Then -2, 4. So we have this graph. Okay, be very careful. We do the dilation first. We do the scaling first. Okay. So this is a graph of 2 times absolute value of X, or 2f of X, right? You see that's multiplied by 2 is f of X. So this is the graph of 2 of X. Now adding 3. Adding 3, we add the function value. 4, 3 becomes 7. So 0 adds 3, we get a 0, 3. 4 plus 3, that's 7. Okay. And the by symmetry, so we have this. Sorry. Right. This is a straight line. Straight line. Okay, so this is 0, 3, 2, 8, 7, negative 2, so negative 2, 7. Okay, 3 points are enough. So this is the graph of g of x, which is 2f of x plus 3. So the next question is called piecewise function. So why is piecewise? You see, we have two pieces, right? Before f of x only equals to one thing, but now f of x equals to 2x if x is less than or equal to 0, or x squared if x is greater than 0. So first, let's evaluate this. So f of -5. So let's graph this actually. So we have a 0 here. So first piece is x less than or equal to 0. So from here. So that's this one. Let me use green color for the other one. Then we have this piece. That's not including this with the open circle to the other end. So with the blue color, the function is 2x. So this on this domain f of x equal to 2x. But on the other end, f of x equals to x squared. Right? Just like one person doing two jobs. Right? At home, she does chores. In school, she teaches. Just like that. Think that way, okay? So now let's see f of -5. F of -5 in where? In blue or in green? In blue, right? -5 is somewhere here. So that means f of -5 will apply 2x function. So 2 times -5, which is -10. Then f of 0. F of 0 is also in blue, right? So that means we do 2 times 0, which is 0. Then f of 3. Well, where is 3? 3 is in blue or in green? 3 is in green, right? That means we need to apply the green function, which is 3 squared, which is 9. So this is called a piecewise function because we have different pieces of the graph. So how do we graph this? Let me just erase. Let me erase this. Erase this so we could use this grid to graph it. 2x is a linear function. So we just pick up a value. So 0 is there, 1 is there, right? So have 0, 0 point. Then if I can pick a -5, if x is -10, that's too big, let's pick a -2. Right? Oh, I cannot use green, I use blue color. This is my blue part, right? Pick a -2. So -2 times 2, that's -4. So I get -2, -4. I get this point. So with these 2 points, I can graph, and x goes to -infinity on the blue part. Right? So that's this piece. That's the graph of the first one. Second one, let's use green color. So 0 is not there, but let's pick 0 anyway. If it's 0, it's 0, but we have open circle. But the open circle overlaps with this solid circle. So now let's pick 1. Well, 1 squared is 1. So we get this one. And 2 squared is 4. 2 squared is 4. Right, so we know how to graph quadratic, right? So not a straight line, but wiggled. So that's it. That's the graph of this function. You see two pieces, the blue piece and the green piece. And it so happens they intersect at 0, 0. But that's fine.
Yeah, so I'm not basically where it works with the
Let's see 7.
this year.
So 7, we have 3 pieces, right? We see the domain. Let's use black color. What's my dark? Okay. So my domain X be split into 3. First, let's see 0 here. Let's use red color for the first one. We have X less than -2. Let's see -2 is somewhere here. Less than, we know the graph goes this way until infinity, right? Then the function is f of x equals to -3. The middle one, let's use blue, is from -2 up to 1, including both. So from -2 up to 1. Let's see, this is 1. So from here, for the solid, up to 1. Also solid. And the function is f of x equals to x squared. And then the third piece, let's use green. X greater than 1, but not including 1. So let's use circle up to path to infinity, and the function is defined as 2x plus 3. So you see one function has 3 different behaviors in different domains. So now let's see. Let's change the color. So -4. Where is -4? We see -4 is somewhere here, right? So it belongs to red. So if it belongs to red, we go to the red. That equals -3. Then -2 belongs to the second, the blue. So -2, f of -2, we need to follow the blue, which is x squared, which is -2 squared. The 4. Then f of 2 is in the green. So we need to follow the green. The green is a 2 times x, 2 times 2 plus 3, which is a 7. Now we want to graph. How do we graph? Let's graph the red color first. So red color starting from -2. Starting from -2, right here. And the function value is -3. -3 is here. -2 with open circle. And the -3 is, oops, this is bad.
Yeah. So I just said obviously.
Let me use this. So this is my f of x equals to -3, constant function. The second one, let's use blue color. Blue color, so start from -2, solid. When it's -2, the value is 4. So -2, 4, solid dot. Yeah. And then this is a quadratic, we know the graph. So if 1 equals 1, -1 equals +1, because -1 squared, right, from here up to, but only up to 1. So 1 also solid dot. So it ends at this point. So that's my second part, second piece. Now let's see green. Green starts with, not starting with 1, but greater than 1, right? But we'll have to evaluate 1 anyway. So 2 times 1, 2, 2 plus 3, 5. So 1 and 5, but this point is not in it. Make an open circle. Then let's get another point. So 2 equals to 7. 2 equals 7, get this point. So this piece is f of x equals to 2x plus 3. Let's read for the blue also. Blue is f of x equals to x squared. Okay, so we see the domain of the x-axis, the domain is split into 3 parts, 3 pieces, a red piece, blue piece, and green piece. That's why this kind of function called a piecewise function. So when we graph it, we have we have 3 pieces. Okay. Of 3 pieces, a red piece, blue piece, and a green piece. Okay, I think that finishes this lecture.